In the previous session, we talked about variation, and we measured every part to monitor that variation. In this session, we're going to talk about sampling. And what sampling is that sometimes it's not practical to measure every part. So we want to just kind of get a sampling of the part. So you can think of it like this. Let me go down here. I'm not sure how many voters there are in the United States. I'm going to say somewhere around 100 million voters. And when we have a presidential election, um, typically there's two main presidential candidates. And prior to the actual election, they try to determine who is going to come out ahead, who's going to be elected. And to do that, they don't call all 100 million voters and ask them who they're going to vote for. Instead, what they do is they might call 5,000 voters, and they might find out that candidate 1 has 30%, candidate 2 has 40%, and maybe there's some other voters in there, and then undecided, they don't know yet, is 20%. So this might be 3 months before the election. They call out 5,000 voters, and these are what the results are. This is a sampling of the population. So over here, this is called the population, and this is a sampling of that population. So they can expect over here that this sampling is going to represent pretty close to how it would come out over here. So again, candidate 1, they're expecting it to be pretty close to 30%, 2 pretty close to 40%, and 20% undecided. So without going through the effort of calling every single person, which isn't practical because the election would probably be over by the time they finish that, they call a subset and just do a sampling, and that's going to represent that population. Now, getting back to SPC in the manufacturing facility, the same thing is kind of true. If we are running 100 parts in a day, that's pretty easy. We could probably do 100% sampling. So in that case, we could measure every single part and enter it into the system. That's realistic to do. But if we were doing 1,000 parts per hour, now that can get challenging. Maybe we have some automatic equipment, a vision system or something like that that could measure and enter the parts into the system. But if we're doing those by hand, that's not so practical. So we may do every hour, we might pull off 10 parts in our sampling and hoping that that will represent our population. So for example, if we get into the details of that, in our last sample or session, we had measurements. Okay. And we had our frequency. So we had our diameter and our frequency. Okay, so we start measuring these 10 parts. And we get this nice distribution. We get a nice bell curve there. And we are hoping that that represents our population over here. Now, obviously, if we were to measure our population, and with all the same criteria here, or measurement ranges, we might have all kinds of little, measurements here, but I'm going to show them as bars here. We're hoping that this will represent this, but we did not have to go through and measure every, part coming down the line. The other scenario you run into also is that if it's destructive testing, let's say we're measuring tensile strength on a part, so we actually have to put it into a testing machine that actually destroys the part to find out where the breaking point is at. And in that case, you can't destroy every part you're going to produce. You will have nothing left to sell. So you do a sampling, and that's usually a very small sample size. And the that should represent what your other parts are as far as the tensile strength. Okay, there's a couple ways that the sampling is done. One is that the parts are coming down the line, and at some frequency you're going to take sampling. So maybe part one comes down the line, we take a sample, and then part the 100th part comes down the line, and we take another sample, and the 200th part, and the 300th part, and so on. So we're taking one sample, one measurement every 100 parts. And you could do it by time, you can do it many different ways. But another way that it's done is we want to take 5 samples each time. So part 1, 2, 3, 4, and 5. Part 100, 101, 102, 103, 104, and so on. So you get the idea. To 204, 300 to 304. So we're taking 5 samples here, 5 samples here, 5 samples here, 5 samples here. So this few terms that we'll talk about here, this is a sample. This is a sample. Okay, that's where we're sampling our data. Now, what size is that sample? In this case, we have a sample size of 5. In this case, we have a sample size of 1. So we have sample size is basically equal to the number of measurements in our sampling. Actually, I'm going to say in one sampling. Okay, so we have one, how often we do it. In the Ignition SPC module, we call that interval. We'll talk about that more later. And then you have how many measurements, which is your sample size, each time we take a sampling. So you're probably sitting there with the question in your mind, how do I know how often to take a sample and how many measurements to take? And that's beyond the scope of the SPC module. That goes back into quality, and where your quality manager or quality experts are going to, they go through a process to determine that. But we just need to know how many samples or how many measurements in a sample, basically our sample size, and then the interval of how often to do it to represent that population.